So let's take a look at the same problem, but this time let's use the graphing calculator. So again, let's remind ourselves that the mean pulse rate is 69.58 beats per minute with a standard deviation of 11.33. And as always, because our data is normally distributed, I'm always going to make a sketch of a bell-shaped curve. So even if you're using your graphing calculator, a sketch of this bell-shaped curve is very helpful. So again, identify or label the mean value at the center of the distribution. And in this problem, we want to find the pulse rate separating the lowest 2.5% and the pulse rate separating the highest 2.5%. So we're going to call the pulse rate that separates the lowest 2.5% x sub 1, and then the pulse rate that separates the highest 2.5% x sub 2. So let's go ahead and mark that on our distribution and try to make it somewhat symmetrical. X sub 1 on the left, x sub 2 on the right. Okay, and then we have an area to the left of x sub 1. Convert it 2.5%. Always convert it to its decimal equivalency. Okay, and then the area on the right tail has the same area, so that's also 0.025. Okay. Now, to find x sub 1, so to find x sub 1 on your calculator, the function that you use when you know the area and then you're trying to find the missing value is the function that we called inverse norm. So inverse norm. You can find inverse norm on your calculator. So follow me on the right-hand side here and take a look at the screenshot by pressing the second button and then the vars button, which on top of vars you'll see in blue is distribution. And then you're going to go down and choose the option for inverse norm, okay? So inverse norm is going to ask you to type in an area. So what I have here is the newer version of the graphing calculator. So the newer version will prompt you to put in an area, and it allows you to choose left, center, or right. So because I'm searching for x sub 1, the area that I have is 0.025, so you'll see I have that. And it's identified as the area to the left of x sub 1. However, if you have one of the older calculators and it doesn't give you a prompt like this screen here, it's not going to give you the option to choose left, center, or right. So your calculator is always going to default to the left. So you just have to remember that the first number that you type in is always the area to the left of either your X value or your Z score. Okay, so here I'm going to type in 0.025, and then the next number that you type in is going to be the mean value. So let's type in 69.58, and then the third number that you type in is the standard deviation, 11.33. And then when you press enter, okay, it's going to give you 47.37 beats per minute, which is exactly what we calculated when we used the first method, which was using the z-score formula and the table. Okay, now let's talk about how we would find x sub 2, so the pulse rate that separates the top 2.5%. So I'm working at the bottom of the screen here because I'm kind of running out of space. But again, on your calculator, you would use the function inverse norm again. So inverse norm. Now, again, if you have one of the newer calculators, so take a look at the screenshot on the right here, right? You can simply put in the area of 0.025, and instead of choosing left, you have the option where you can choose right. But what I have on the screen here is I have what you would type in if you have one of the older calculators, which again, always defaults to the area to the left. So I want you to take a look at the bell-shaped curve that I have here, and I'm about to circle something in blue. So x sub 2 is the variable that we're trying to find, and the area to the left of x sub 2 is everything that I'm shading in blue, okay? So when you type in the area to the left on your calculator, the area that is in blue represents 1 minus the area that is on the right tail, which is red. So you're going to have to type in 1 minus the area to the right. And the reason why I'm doing 1 minus is because the total area under the curve is 1. So if I know that the area to the right is 0.025, then if I subtract it from 1, it's going to give me the area to the left, which is the area shaded in blue. So that's what you would type in. And then again, you would type in the mean value, which is 69.58, and the standard deviation, 11.33, and press enter. And the calculator is going to give you the same answer or something very, very close to what we got using the other method. So 91.79 beats per minute.